Okay. Few more people. Hello everybody, my name is Andrzej. I'm a solution architect at SoftwareMill, a Polish software house. You may know us from our technical blog, Scala Times newsletter, Scala conference, and few other open source activities, mostly from Scala world, but not all of them. And the plan for today is to talk about event sourcing. Since you've joined this session, I suppose that explaining basics of event sourcing is quite pointless. I have a feeling that most of you are already quite familiar with this concept, but there is no presentation about event sourcing without this boring slide. So let's get it over with very quickly. In classic systems, we are saving our entities, aggregates to the database as the most current state. And if we need to change it, we will simply overwrite this state. In event sourcing, state in database not exist anymore. I mean, you can save a snapshot of the state usually as a performance optimization, but this is totally optional. What you are saving and what is your source of truth are events. And when you reply event by event, you will get exactly the same state as on the left side of the slide, so a shopping cart with two items A and B. But with events, you will also get more business information. So item C was added and then removed from this shopping cart. It looks like a pretty interesting business information. Maybe based on that, we should send some voucher for this item to the user. Maybe we should figure out some replacement for this item. Maybe at this point, this information is irrelevant, but what is crucial here is that you as a developer should not decide which business facts are important and which are not. You should store all of them and provide necessary data when needed. And fun fact about event sourcing from one of Greg's presentation, by the way, if Greg Young is one of the event sourcing evangelists, if you don't know this gentleman, well, you should definitely Google him. So the fun fact is that humans have been using event sourcing for thousands of years. The first, let's say, implementation of event sourcing was found in Mesopotamia 9,000 years BC on clay tablets, and it was used for persisting marketplace transactions. So how many ships, bread loaves, grain were bought or sold, and this way the Mesopotamian trader could very easily recalculate the state of possession. Not by doing this manually, but like counting ships, and in this case, this trader could use clay tablets for that. And in 2005, another famous gentleman wrote an article about event sourcing where you can read such sentence. Enterprise applications that use event sourcing are rarer, but I have seen a few applications or part of application that use it. And this is kind of sad. 11,000 years in total seems like enough time to validate some concept on production, don't you think? And fortunately, we have 2022, or unfortunately, it depends how far east you live in Europe these days. But let's say 2022, and from my observations, which are totally biased, of course, but from my observations, this concept is finally getting more and more popular each day. Why? Simply because we are building completely different systems than 50, 20 years ago, and at some point, you simply don't have a choice. To move forward, to expand, to scale rapidly, you will either end up with something very close to event sourcing or with full event sourcing adaptation. Why event sourcing? Why should anyone bother? As I mentioned, with event sourcing, you will get complete log of all state changes in the system. This is especially useful for your business. No data is lost, but for you as a developer as well. So many times when I was trying to find a bug in my system, it was necessary to replay event by event and figure out what's going on. And trust me, debugging this way is a completely different story. It's like time machine, but more real. You can move backward, forward. It's super handy in case of some nasty bugs. But from my client's perspective, they invest in event sourcing because of these two reasons, so performance and scalability, and of course, we'll cover this in details in a minute. And last point, finally, with event sourcing, an asynchronous, decoupled, event-driven communication works like a charm. And thanks to this pattern, you can embrace this kind of communication very easily. Before we jump into more details, let's talk about one more acronym, which is CQRS, so Command Query Responsibility Segregation. In CQRS systems, the responsibility for handling commands and writes is separated from handling queries and reads. And this separation is not only on the software level, but also on the hardware level, so different deployments, different hosts, different databases. And you can implement CQRS without event sourcing, but implementing event sourcing without CQRS is quite pointless. I mean, you can, why not? But it will be really, really hard to squeeze maximum potential from event sourcing without CQRS. That's why these two are implemented more or less together. And during my journey with event sourcing systems, I extracted a few different levels of event sourcing adaptation. And the first level is so-called transactional event sourcing, where in one big transaction, we are saving all events and all read model updates. Very easy to start, zero magic, no eventual consistency, very nice, but of course, the performance of such solution is quite limited. Sooner or later, this huge transaction will be a problem, so updating all read models may take some time. You are forced to use the same database for your events and for your read models, otherwise you will end up with a distributed transaction, which is even worse. Still, I'm not saying that you should never ever implement event sourcing this way. This is actually very good entry level, especially if you are working on a proof of concept and you have no idea how many people will use your application. Maybe no one, like in one of my cases. So yeah, a few more links about it. If you want to deep dive how to implement such solution, just follow the two links from the slide. And as a company, we created very small open source project with an example of such implementation. It's in Scala using Slick library. But even if Scala is not your first language, you should be able to grab the overall concept and just copy-paste them to your project. So a quick summary, easy to implement, easy to reason about, zero eventual consistency, but performance and scalability not so great. Second level. This time, the scope of this problematic transaction is much smaller. We are saving only events in transactions, so append-only operation for a database is very, very fast, very fast write operation, so any database will love to handle. We'll definitely improve the command handling side. There is a new piece on the diagram, the projector. So something needs to read new events and update various read models. And we can scale this part as well because we can launch hundreds of projectors. So we are good, right? Yes and no. Since this level and further, we are entering the eventual consistency world. And this could materialize in two different problems. The first problem may be not connected to the eventual consistency, but if we launch hundreds of projectors, we can by accident increase the database load because they will constantly query the database for new events, and this might increase the load. But let's say it's a very rare situation. The second problem is the lag. How often should I query my database to check for new events? Each 3 seconds, each 1 second. I can imagine many systems when an additional second of eventual consistency is simply not acceptable. So what can we do about this? And before, quick summary, performance and scalability improved, eventual consistency, increased event store load with a question mark and lags. Third level. And we are introducing another piece, which is an event bus. And someone could argue, okay, introducing event bus here is an overkill. I could agree with that, especially if you have 3, 5 projectors, then yes. But in some cases, and actually in many cases, this extra buffer between your event store and your projectors will give you a lot of benefits. So what are the benefits right now? We need to create a database only once for new events, then copy-paste them to the event bus, and then we can launch hundreds of projectors because event buses were designed to handle such loads, so it's not a problem anymore. Unfortunately, the problem of lag still remains. So how often should I query my database? Maybe each millisecond. Yeah, launching 1,000 requests per second to the database sounds like not a very good idea. So we can save events, and in the same transaction, we can send them to the event bus. And of course, transaction on 2 heterogeneous systems is a very bad idea, so quick patch for that. No transaction. I mean, we are saving only events in transaction and then sending them in a fire and forget style to the event bus. This is the fastest possible way to fill event bus with new events, but of course YOLO style is not okay here. At least once delivery is a must, so no events can be lost. Also, the events order must be exactly the same. How to achieve this? We can do this by tracking event sequence number. So each event should have its own monotonically increased sequence number, and if this sequence number is +1, then yeah, I can send it to the event bus. If it's +0 or -1, then this is a duplicate, I can skip it. If it's +2 or more, then I need to fill this gap directly from the event store. And in 99% of cases, you won't see any gaps, but yeah, you need to be ready for some crashes, restarts, etc., etc. And sounds easy to implement, but trust me, it's not. It will require a lot of failover tests, but I can assure you that it's possible. And it's the fastest possible way to have a sync between your event store and event bus. It will be easier to implement in some, let's say, ecosystems and harder in others. Okay, let's validate our architecture. So query services are stateless services. To scale this part, we just need to launch another instance, put some load balancer on top of it, and that's it. Read models, yeah, we can have separate database per read model. We can separate database per query, not a problem. We can launch hundreds of projectors because we'll use some good scalable event bus like Kafka, PubSub, or whatever. Scaling event store. This part is tricky because first we need to talk about scaling command service side. Can we scale it? Command service must be consistent, and to achieve consistency you have at least two options. First one is optimistic locking, and then you are forced to use an event store that will support such locking mechanism. Mostly it will be a relational database, so your scaling capabilities here are limited by scaling capabilities here. If you need to handle huge load with hundreds or thousands of requests per second, then I'd recommend a different strategy and to handle concurrency on your application level and implement something called single writer. And with a single writer here, you can use any event store you want. It could be Cassandra, it could be Dynamo, it could be a distributed database, single host database, it doesn't matter. But scaling a single writer will require a sharded cluster solution with all its advantages and disadvantages. And I hope we will cover this as well later. And here is our final turbo uber scaling event sourcing architecture. Please do not start with something like this. Most likely you don't need it. The idea was to show you the ultimate goal, and now your job is to find this level which suits your needs the best. Yeah, so summary, performance and scalability really high. Eventual consistency, complex implementation, I will not lie. And if you want to read more about this locking versus single writer principle, just follow the link from the slide. It's one of my favorite articles about event sourcing related stuff. To cover this topic fully, I should mention about two other alternatives. So first one is CDC, change capture data, instead of event bus. This is a very nice option, especially if you are using a single host database, then yeah, CDC is really something interesting. But if you are using a distributed database, then managing a CDC would be quite challenging, and I don't recommend it. And because we desire so much streaming capabilities from our event store, maybe we could use event bus as an event store. And here's a link to my CTO article about how to implement event sourcing based on Kafka. And I hope that I'm not signing my resignation letter right now, but be careful with that. I mean, this solution will work really great for very specific use cases, but not as a general purpose solution. So before you jump into it, make sure that you understand all Kafka concepts correctly. Still, really great article. Not covered today, but worth to check. Command sourcing and event collaboration, let's say it's your homework. And okay, so we know what we want to implement now. The question is how. And we have options like custom implementation, library, or framework. And if you look at event sourcing from domain perspective, this is quite a trivial pattern. We have only 3 main building blocks, so commands, event, state, and we need to implement just 2 methods, process command and return list of events, and then persist this event and apply the event and return new version of the state. So many people think that you can implement event sourcing from the scratch by yourself. That's true, but your application will be production ready when you also deliver few more set but require features like snapshotting, failover, recover, debugging, sharding, serialization and schema evolution, huge topic, concurrency access, etc., etc. And trust me, implementing this by yourself is a recipe for a failure. I mean, I would love to implement my own event sourcing framework, but at the same time, I know that I will make all the possible mistakes. So let's use something that is implemented by hundreds of programmers and tested by thousands of programmers. Let's not reinvent the wheel, although using any framework has its hidden cost. Here's a classic JPA implementation. We have some JPA, we have a business entity with some business code changed status to and some JPA annotations. It looks okay, right? No. We just mixed 2 very important responsibilities. First is our domain code and business code, obviously. And the second one is some instructions how to persist this entity. And someone could argue, so what? If I remove all this annotation, the code will be exactly the same. That's true, but at the same time, this is a very, very simple example. And trust me, all tutorials to any frameworks are based on simple examples. So let's say that I would like to use a map of maps in my domain model. Translating such a field to a JPA will be a problem. I'm not sure if it's even possible. Maybe it is, maybe not. Most likely, I will use something more JPA compatible. And personally, I hate such compromises where my persistence layer is dictating me how should I implement my business code. And as Uncle Bob said many times, persistence should be only a plugin to our domain. Unfortunately, the same story applies to event sourcing frameworks. So here's an example from Axon framework. We have user aggregate mixed with some framework annotations. The same story applies to Lagon framework. User entity extends persistent entity. And if you check out the imports, you can see some JSON formats, etc., etc. On my domain level, I don't care about JSON. I don't care about serialization. I just want to focus on my business code. So how to deal with it? And the solution is to back to the beginnings, let's say, and proper packaging. In my domain package, we can put all the event sourcing related domain stuff, so events, commands, state. And application package is a place for your library or for the framework. And if you want to read more, just follow the link from the slide. The repository is pretty old, but the overall idea is still valid. And this way, your event sourcing user, let's say, could look like the snippet on the slide. So simple case class, simple record, just 2 methods. And don't get me wrong, I'm not saying that you should implement your whole business code in just 2 methods. Those are like entry points to your user aggregate. But your imports will look like this. So no imports to any framework whatsoever. And once again, application package for all the set stuff, and domain package for domain logic, domain validation, and in perfect word, 0 event sourcing framework imports. Library versus framework, because I'm using these notions very often. What's the difference? Usually, removing a library from your code base is much easier than removing a framework. And a good example could be Akka Persistent versus Lagom. Lagom is a full-blown event sourcing framework. You just need to put commands here, events there, and Lagom will do the magic for you, which is super cool, unless you have a very, very specific business use case, and then you need to adjust this business use case to the framework. Akka Persistence, on the other hand, is one level of abstraction lower. It will give you all the necessary technical requirements to build good event sourcing solution, but you will need to handle more stuff by yourself. And at the same time, you will get more freedom. Which choice is better? It depends, as usual. The idea is that I'm not saying that you should never use frameworks. Is that you should be careful with your choice. and validate existing solutions. And actually, maybe there is something in between, like a persistent typed. Still not a framework, in my opinion, but this time everything is well organized. It's much harder to do something stupid, and I could honestly recommend it. It's a really nice piece of software. Okay, so we know what we want to implement, how, now, where to store events. And this time the storage selection depends on the previous choice. So if I go with akka persistence, then my choice is limited to, let's say, relation database and Cassandra. This is of course not true. There are many other databases supported, but for sake of this presentation, let's say that I have choice between single host database and a distributed database. And single host database, relational database seems like a safe option for start, because everyone is familiar with this kind of database, everyone knows how to set up it, even maintain on production. So it seems like a safe option, right? It depends. It depends on your load. So if you need to handle huge load and you know it from the beginning, then a single host database and vertically scaling a single host will become a problem sooner than later. That's why I would recommend to use, or at least to analyze, distributed databases like Cassandra. Why? Because with Cassandra, you will get partitioning by design. So your data will be spread across all nodes in the cluster. Replication by design. In case of some node failure, you will always be able to read your data from a different node. Leaderless architecture, so no single point of failure. In comparison to Mongo, let's say, where you have classic leader firewall architecture, and in case of leader failure, strange things could happen. And here, any node can handle any query. Cassandra is optimized for writes, so just 2 nodes can handle 100,000 transactions per second. These are, of course, marketing materials, but it's not enough for you, then you can scale it in a horizontal fashion. Be aware that there's growing alternatives to Cassandra, which is ScyllaDB. Basically, ScyllaDB is a Cassandra without JVM. The same concepts, the same protocols, ideas, etc., but this time it's in C++ and with sister lib. And it could handle even more load. I'm not sure what is the status right now, but it was not fully supported by akka persistence. As I mentioned, not sure what is the status right now, but if you follow the link from the slide, you will be able to verify it by yourself. Okay, so we know where to store events, now how to store them, and we have options like plain text, so JSON, XML, YAML, and binary formats. And I know that most of you will choose JSON anyway, but let me show you some alternatives. First, let's discuss plain text versus binary. Plain text for sure is human readable. It's very convenient to just select some events from your event store and analyze them directly from the query. In case of binary, an additional step is necessary to translate bytes to something human readable. And of course, such tool to translate this data should be created up front, but there is nothing like a good motivation, and burning production is the best motivator you can imagine. With JSON, you might face some really strange problems with number precisions. If you're interested more, just follow the links from the slide. By definition, binary formats are more compressed. The actual saving depends on your events model. In my case, it was from 60 to 70% of saving on a disk space. And someone could argue, okay, storage is cheap, so this is not so relevant. Yes, storage prices usually go down, but at the same time, the amount of data we are gathering is growing even faster. So, and if you check the prices of good, large SSD drives for DB purposes, actually the prices are not so cheap in my opinion. And most of the benchmarks are pretty consistent. Binary serialization is much faster than plain text serialization. And yeah, the last point is really important, full schema evolution support. With good schema evolution support, you will be able to versioning your events without typical versioning pain. So no more underscore v1, underscore v2. Let's use schema evolution for that. And in case of binary, the support is on a completely different level than in case of plain text, like JSON. So clearly, binary formats are pretty nice options. So now, which one should we choose? Java serialization is slow. It's dangerous. Let's not waste time on it. Cryo, very nice, very fast, but it will work only on JVM applications. So let's not limit our architecture only to JVM application. Thrift from Facebook, very nice, very rich when it comes to functionalities, and it's more or less the same as protocol buffers, but I know the second better. So we have Avro from Hadoop versus protocol buffers from Google. And now I could spend another 40 minutes or so just explaining the difference between two of them. So we will do this very quickly. Both will support many languages, although the actual level of support might be different. So in case of, let's say, Avro, the support in Python, yeah, you are forced to use the Avro generic approach, generic schema approach. When it comes to protocol buffers, the support in Scala is way better than in Java, in my opinion. Speed, both are really fast when it comes to speed. Both will produce very small payload size. Full compatibility support. Why do you need full compatibility support? Yeah, first, backward, you need to be able to read old events from your database, which is obvious. But you need to also forward compatibility. So in case of rolling updates, or in case you want to introduce new event version without the need to update all projectors or consumers of this event at the same time. With forward compatibility, you can do this anytime later you want. And in both cases, there is a tie again. You can add the field, remove the field, even rename a field. From my perspective, it's easier to do this in protocol buffers, but it's possible in both. So what's the difference? And the difference is in schema management and the overall impact on the domain. So in case of Avro, most likely you will be able to generate Avro schema based on your code. So the code is first. This way you will create less boilerplate code, but at the same time you might pollute your domain with some Avro specific things. Not to mention about reader and writer schema distribution, which is quite painful from my perspective. In protocol buffers, the schema is first, and you will generate, based on that schema, you will generate some classes, and the generate code is so ugly that you will create another model. So you will have events for serialization and your domain events. And because of that, you will need to create a lot of boilerplate code, so translating from something serializable to domain and from domain to something serializable. But from my perspective, I can pay this price because I love to have clean domain with nice objects, etc., etc. Which choice is better? You know, it depends. If you are working on a high-frequency trading application, then both of them are not good for you. But let's say it's a generic presentation. And the idea behind this slide is that serialization is a really, really important topic. And you should do this as carefully, create some proof of concepts once again. And if you want to read more about all the slides I just skipped, just follow the link from the slide. Yeah. The last big question is what should we put to the event payload itself? And most people will start with delta event. So let's say that I would like to emit user funds withdrawn event. And in that event, I will put only the withdrawal amount. This is fine, it will work, but from my perspective and from the projector perspective, it will be quite painful to process such event. Let's say that I would like to implement a functionality that will send an email to the user if we spot that the current balance is below some threshold. So it will be nice to enrich such event, yeah, like user funds withdrawn, with the actual balance. This way, the projector implementation will be super simple. You don't have to calculate anything. You don't have to query external resources. Just simple if. That's it. And the extreme version of events enrichment is to put the whole state to the event. I've done this once, and I'm not sure if that was a good idea. If in this particular case, maybe it was. But yeah, the events enrichment, and I think it should be a default choice. It's way easier to handle them later. Besides business data, most likely you will add some technical metadata like sequence number, creation timestamp, event ID for the duplication, let's say, command ID that was the source of this event, correlation ID if you want to spot the whole business process across many services. So now we know everything. We know what we want to implement, how, where to store events, how to store them, how to compose event payloads. So let's implement some event sourcing in our ecosystem. Where? Everywhere. No. This is the first major problem with event sourcing adaptation. As you already noticed, I hope so, this pattern is really powerful, but at the same time quite costly. So there is no point in implementing event sourcing everywhere. In your core domain, you should choose even some subset of this domain, and maybe this is a part ready for event sourcing, maybe not. So remember about this slide, and now we could focus on more classic problems like the time required to replay all events and rebuild the state. Surprisingly, this is a really fast operation to load 100 events, even 1000, and recreate the state, but many people ask about it, so we can start with it. If this is a problem for you, then you can enable snapshotting. So make sure that your event sourcing framework library supports snapshotting. But before you enable snapshotting, make sure that you really need it. Create some benchmarks, check the loading time, etc. Because the hidden cost of snapshotting is that then you will need to handle the schema evolution of the state as well, not only of the events. Another strategy for this problem could be to go with write-through cache and basically load everything and keep everything in memory. That's why event sourcing based on Akka stack is so damn fast, because everything is loaded into memory. And if you need to handle next command, basically the state is waiting for you. It's hard to write anything faster than that. The technique is called write-through cache. And if you want to read more about it, once again, follow the link. Okay, because everything is memory, you can expect memory consumption problems and out-of-memory exceptions. Make sure that you are not doing anything strange with your state. Learn how to use memory analyzer tool, and you should be fine. And yes, another question about the state: should my state be immutable or not? By default, of course, immutable. But as usual, it depends. So in my case, when we are using immutable list, we are able to deliver 17 operations per second. And then we switch to good old-fashioned Java tree map, 2200 operations per second. And this difference is so huge that it cannot be simply ignored. That's why we go with mutable state. Still, I'm pretty comfortable with this decision because the actor is our state guard. So yeah, we don't expect any problems with concurrency. Although I need to remember that I cannot simply return the state. I just need to create a copy before I do this. Fixing the state. This one is boring. This one is boring as well. Handling duplicates. Oh my God, this is a nightmare in distributed systems. So let me tell you a story. This is a fairyland, and this first unicorn is called exactly once delivery, and the second one is called transaction between two aggregates. None of them exists. And you know, I'm a happy father of twin sisters and a boy, but let's focus on twins. So when I'm saying that there is no such thing as exactly once delivery, I know what I'm talking about. Yeah. So why duplicates? First of all, we can create duplicates in this part on the producer side. Even if you are able to filter out duplicates here, our projectors, our consumers should always be ready for duplicates. And how to handle this? Well, the easiest solution is to have idempotent updates. So in this case, consuming the same event twice will not change anything. And this is super cool, although some projections are not idempotent by definition. So let's say we are calculating average, and then processing the same event twice will corrupt the results. And in this case, we need to achieve something called effectively once delivery, or basically deduplication. So for that, we can, in transaction, save the read model update and current sequence number, so that if we processing this next event, if it's +1, then we can process it. If it's +0 or -1, this is a duplicate, we need to skip it. If it's +2 or more, then it means that we have a gap in our event bus, and the only thing we can do on the consumer side is to throw a nasty exception, because the problem is on the producer side. So that's the solution for this problem. And the tricky part here is that not all read model will support such transaction. So update if sequence number is +1. For example, Redis. Transactions in Redis are something different than transaction in SQL database. So make sure that your read model database supports such transaction and such query, update if. If you don't have sequence number, you can use also event ID for the duplication, but this time you will need to store some history of events ID, let's say last 1000 event IDs. It will be fine as well. Broken read model. When we can broke our read model? So two main reasons for that. Software reason, so a bug in the code, not handling duplicates correctly, etc. And a hardware reason. So Redis, once again, very good example. In case of Redis, you should expect always some data lost, and actually quite a lot of, depending on the configuration. And thanks to event sourcing, you can always just drop the whole read model and recreate it from the start. This is one of the most important features of event sourcing. I use it many times, and it saved my many times on production. But sometimes processing billions of events just to recreate read model because of the hardware issue, not because of the bug in the code, it will take too much time. In this case, we can use, let's say, technique called manual offset management. Yeah, it's technology dependent. If you have this offset from your event bus or from your event stream, then you can save it together with read model update in transaction, and then in case of hardware issues, you just need to read the last successfully saved offset and start processing events from that offset. So that's the solution. Multi-aggregate transactional update, the second unicorn. So if you ever need to update two aggregates at the same time, it's time for a pause. Start with rethinking your aggregates boundaries. Maybe you have two thin aggregates, and if you join them together, you will eliminate this problem very easily. Sometimes aggregates boundaries are fine, and you still need to handle it. So how to do this? The only way to do this right is to apply compensating action. And compensating action could be optimistic or pessimistic. These are not official names. I just made it up to explain you how to approach to compensation. So let's say that we are building very simple application for buying tickets to some cinema shows. And we have two aggregates. User account aggregate, which represent user with some funds, and we can charge the user. And cinema show, where we can reserve the seats, and we cannot sell more seats than available. So in case of pessimistic compensating action from the user perspective, first, we will charge the user, because it's pessimistic. Then we will book the seat. And it was the last seat, so all seats are sold out. Unfortunately, our applications are used by many users concurrently. So right after charging the first user, another user could book the last seats, and it will be nice. And so this booking will fail, and it will be nice to have transaction here. Forget about it. Look at it as a transaction between, not aggregates, but between microservices. And you know that transaction between two microservices is a problem. And as I mentioned, to fix it, just need to apply compensating action. From the optimistic view, first we will book the seat, and then we will charge the user. So in case of concurrent booking, we will enter overbooked state. And now, should we charge the user? Well, in case of cinema business, I suppose it's not a good idea, but in case of flights and plane tickets, etc., overbooking is fine and it's a part of business strategy. So different business needs different solutions. The only thing missing here is how to implement this. And for that, you will most likely end up with a Saga pattern. You can implement Saga as a choreography, which is basically reading two or more event stream from different aggregates and checking for some inconsistencies. Or you can go with orchestration, where you have a single place with the whole business process. And from my perspective, choreography is much easier to start and it's much easier to implement. But with time, it might be pretty complex to analyze what is going on with the system. Then it will be okay to go with orchestration. And piece of advice from my side, try to avoid sagas if possible. If not, then you can sometimes expand your aggregate boundaries a little bit and go with finite state machine in your aggregate, and this way you will simulate Saga, let's say, inside an aggregate. This is a really huge topic and we don't have time to cover this in details. And Saga seems like a very easy concept, but it's not. It should be persistible, it must survive restarts. You cannot assume any order of events, so events order should be relevant. There will be always some time window limitation, so let's say that I'm checking for inconsistency within 10 minutes window, and then I'm applying the compensating action, but some events might arrive to us after 12 minutes. That's why compensating action must be commutative. Few more links about Saga for you if you want to read more. Yeah, event sourcing and Rodo. Yeah, this should be super fast. So your application should give user something called right to forget, and how to do this in event sourcing where you cannot delete events. In fact, you can, but yeah, you should avoid it. The technique here is called data shredding. Basically, it's encoding sensitive data with some encoding key. So in case you need to delete user data, you just need to delete encoding key for this data. Sounds easy, but yeah, not so easy to implement as well. Managing this encoding keys is quite challenging, not to mention about some retention policies of your message brokers, backups, logs, and data before Rodo GPR migration. A piece of advice from my side, do not use event sourcing for Rodo GDPR stuff. User ID is just fine. In case of such data, just simple CRUD application is also okay. Okay, in our final version of architecture, I mentioned that we will use a sharded cluster solution. And with any cluster solution, you should expect a very nasty problem, which is split brain. Who knows what is split brain? Okay, a few people. So I will explain it very shortly. So let's say that we have a cluster with 5 nodes and some load balancer on top of it. Load balancer is a dummy machine. It will just route all the requests to all nodes in round-robin fashion. And the first request to update user with ID 1 will be redirected to node 5. But node 5 is in a sharded cluster. So this node is aware that the actual node responsible for updating user 1 is node 1. So it will redirect this command to node 1. And then we have a failure in our DC, a broken switch, some connection problems, etc. From the load balancer perspective, nothing changed. All nodes are working fine, but node 1 and node 2 cannot communicate with 3, 4, and 5. Because of that, they will create 2 smaller clusters. And this time, command to update user 1 from node 5 will be redirected to node 4, because in this smaller cluster, node 4 is responsible for user 1. But in this smaller cluster, still node 1 is responsible for user 1, and there you have a classic split brain scenario. And yeah, recovering after such failure is quite pain. And some data can be lost. So what can we do about this? Be aware of this problem. In Akka stack, there is a dedicated solution for that, which is a split brain resolver. Make sure that you will enable it and configure it properly. Also, you should enable very good monitoring and alerting of your cluster so that you should know 24/7 what is going on. Prepare a lot of failover tests, create your own chaos monkey. Cluster should be deployed not only on production, but also on dev and staging environment, just to test it more. And keep it as small as possible when it comes to code base and number of nodes. So managing the cluster with 15 nodes, I mean, with 5 nodes is much easier than with 15 nodes. So if some functionality can be moved to a stateless service, just move it to the stateless service. Okay, summary of this whole presentation. Event sourcing is great. It's awesome. You will love it the second time you use it. The first time will be painful. Because of that, carefully choose your event sourcing library or framework. Really, take some time, validate existing solution. This is a really important decision. There is no perfect database for event sourcing. Only reasonable compromise. Yeah, that's the truth. Spend some time and learn about schema evolution support, schema evolution about your events, commands, event state. And I'm not talking about days here. I'm talking about weeks sometimes. Yeah, eventual consistency is your friend. Do not fight with it. Just learn how to deal with it. Scaling is complex. Launching Kafka cluster, Cassandra cluster, Akka cluster will require a lot of work, but the reward will be proportional to the effort. And this whole event sourcing is basically turning your database inside out. It's a great way to communicate between microservices. Unfortunately, we didn't cover this topic too much. And the last point, a little bit philosophical. So if you create your first application, which basically the core is processing stream of events, you will realize that all big players are using the same techniques. So Twitter, Facebook, Netflix, they are all using the same patterns. Most of the DB engines are using the same techniques because this is the recipe for building reactive, elastic, easy to scale distributed system. Definitely worth to learn it, definitely worth to expand, to extend your skill set with that. And it will change your mindset, trust me on that. It will change your mindset in a good way. And if you don't have time to learn all this stuff by yourself, let's say some time ago as a SoftwareMill Academy, we launched few online on-site courses where we can teach you how to start with actors, how to build reactive event sourcing solution, how to scale them with Akka cluster, and then how to measure the performance of such solutions. So if you are interested, more links on the slide. And that's it. Thank you very much for your attention. If you have any questions whatsoever, you can do this now or later as you want. Thanks. Questions? No questions.